charge moving, it should not be a neutral. Like a neutron movement will not produce any current, but a proton moves or an electron moves, produces current. And if it is the movement of protons or if it is the movement of positively charged particles, that current is called as conventional current. And if it is the movement of negative charge, then the current is called as electronic current. Always remember that direction of electronic current will be in the opposite direction to the movement of electrons, and the direction of conventional current will be in the same direction of movement of protons. So, positive charge, current in the same direction, negative charge, current in the opposite direction. This current is called as conventional current. This current is called as electronic current. Then I taught to you mathematically what is current. Current is charge per unit time. Charge is in coulombs, time is in seconds. So, coulomb per second is also called as amperes. That is the SI unit of current. Current is measured in amperes. And what is the definition of current? Current is defined as rate of flow of charges or charge per unit time. So, how to find charge? Will it be directly given? Sometimes directly given, most of the time not given directly. You have to find the value of charge with the formula of quantization, which is Q is equal to N into E. What is N and what is E? N is an integer and E is called as basic elementary charge. Basic elementary charge, its value is how much? 1.6 times 10 to the power minus 19 coulomb. Now, this concept, that is Q is equal to NE, I is equal to Q by T, you can expect one question to surely come in the board examination. From this full theory or the numerical part, whatever it may be, this concept, one question will definitely come in the board examination. First category of question can be, they may ask whether a particular charge is possible or not. That is, if they will give the charge value to you and they will check whether this charge is possible or not. How to find that? If you put the value of Q, put the value of E, divide Q by E, you will get N, and N comes as an integer, it is possible. If N comes as a fraction or a decimal, not possible. For example, if I give you the value of Q as 3.2 into 10 to the power minus 17, and E you already know. So, what is the value of N? N will become equal to Q by E. Q is 3.2 times 10 to the power minus 17, and what is E? 1.6 10 to the power minus 19. If I do, it will become 2. It will become 10 to the power minus 2 will go about plus 2. So, it becomes 200. Now, 200 is an integer. This charge is possible. But the same question would have come like, is a charge of 3.2 times 10 to the power minus 21 possible, minus 21 coulomb possible? Then if I check N, it will come 3.2 times 10 to the power minus 21 divided by 1.6 times 10 to the power minus 19. When you solve this, it will become 2, and this will become 10 to the power minus 2, which makes it 2 by 100, 0.02. Can we have 0.02 charge? Not possible. It's like meaningless to say we have 0.02 electrons or 0.02 protons. Meaningless, isn't it? So, by checking the value of N, we can identify whether this charge is possible or not. N can be? N, see, negative N indicates that it is produced by electron. Positive N indicates that it is produced by proton. Negative, nothing has to do with the magnitude. Negative in the case of charge just indicates that it is produced by electron or produced by proton. So, that is why in some books you will say plus or minus will be written in front of it. Plus means it is for proton, minus means it is for electron. So, this is the first category of question. The first category of question is, ask me, Nitin.
Sir, whether the magnitude of each individual charge was found first, or the number of electrons or protons in 1 coulomb of charge was found first?
You are saying that, come again with the question, what was found first, whether it was, whether
E was found first, the elementary charge, or the number of protons or electrons in 1 coulomb of charge was found first.
First, what was found is number of charged particles in an atom, it was found first. Only then we could determine what is the basic elementary charge value by the Millikan's oil drop experiment. You will learn that experiment
here.
here.
Analyzed it by seeing or?
No. There was experiment.
Came up with it.
No. They did experiment. That experiment is called as Millikan's oil drop experiment. That experiment will come in 12th standard for you. They have removed in syllabus, but I will teach you when you come to that level. And that experiment proves that how the value of E is 1.6 times 10 to the power minus 19 coulomb. Understood, Nitin? Yes, I'll come back. So this is the first category of question, or the question will come like time is given to you, number of charged particle given to you, and they will ask you to find the current. Number of particle given to you, multiply by E, you will get Q, divide by time, you will get current. This is the second kind of question that comes in the examination. Remember this, they will give you Q, not directly, they will give you N. They will give you time, multiply N into E, you will get Q, divide by time, you will get current. Or they may give you current, they may give you N, they will ask you to find time. So I is there, N is there, N into E you can multiply, get Q, I by Q or Q by I will give you, by this formula you can solve, Q by I will give you T. These kind of questions will come. I may be given, T may be given, they may ask you how many charges have moved. You can find I into T will give you Q, and from Q you can divide by E, you will get N. So any question from this category is possible. I, T given, finding Q, Q, T given, finding I, or Q, I given, finding T. Anything may come which can easily be found by this formula if you have understanding of this formula. Next in this chapter, we have learnt about the meaning of the word potential difference. So I said you, potential difference is what? Work done per unit charge to move it from one place to another place, one point to another point. How much is the work done per unit charge to move it from one point to another point? That is known as potential difference between 2 points. Remember, work done is in joules, charge is in coulombs, joule per coulomb is called as volt. So SI unit of potential difference is volt. I even taught to you, whenever you want the charges to move, why charges, anything to move, you must have a potential difference. For example, if I am having a plank in front of you and if I keep the pen on this plank, the pen will not move. But if I create a potential difference, the pen starts to move. So why did the pen move? Because I created a potential difference between these 2 points. You learned about potential energy in 9th standard, right? Potential energy. What is potential energy? Energy possessed by the body by the virtue of its height. Just because you increase the height, it has more energy. It has less energy. It will go from higher energy to lower energy. So whenever you want something to move, you must have a difference in the potential. For example, air, wind is there, no wind. Why wind blows, you know? Because air always goes from a higher pressure area to lower pressure area. That's why the wind blows. Water, tank is always on top, tap is in the down level. So tank being on the top is at higher potential. When you open the tap, water comes because it travels from higher potential to lower potential by itself. So if you want in a particular circuit charges to move, then what you should have? Some potential difference you should have. For example, if I am having a circuit like this, and in this circuit you want the electrons to move. One thing I told you, that the current which is produced in a circuit is because of the movement of charged particles, and the movement of charged particles happens when you create a potential difference between them. Suppose I am putting a battery here. The moment I put a battery here, the battery creates a potential difference because the positive terminal is at higher potential, the negative terminal is at lower potential. Now there is a potential difference created between higher and lower point. The electrons in the wire automatically starts to move. Just because you kept a battery in a circuit, the charged particle starts to move because there is a creation of lower potential, higher potential. And by the tendency of any matter, it always moves from higher potential to lower potential. The problem happens when the charge will reach at this point, lower potential, because it has to go from lower to higher. That will not happen by itself. Water from tank to tap comes by itself, but water from your ground to the tank does not go by itself, right? If you open the tap, water comes. Why? Because the tap is at lower potential, tank is at higher potential. But can the tank get filled by itself until you put the motor? Only if you put the motor, the tank will get filled, isn't it? So some energy has to be given from you externally if you want the water to go once again in the tank. The same thing happens here also. If you want the charge to move from lower potential to higher potential, what do we need? We need some energy. Who gives that energy? Chemicals inside the battery. So remember that when you buy a battery is made up of some chemicals. It can be lithium ion battery, it can be nickel cadmium battery, it can be some other chemicals also. So these chemicals react and creates chemical energy, and this chemical energy only is pushing the charges from lower potential to higher potential. See, this is a very deep concept. It will be useful for you till the 12th standard gets over. Remember that. What I am teaching to you, it may not be there in the book itself, whatever I am teaching you now. But this is the concept which you should understand, because generally what people think, I buy a battery will have charged. Generally people think like that. I put the battery inside the remote starts working because current is given by the battery. You think battery gives current. You think this point gives current. No. For current to come, we just need electrons, and whatever appliance you have, it has some wires inside, right? That wire itself has all the electrons. But since the electrons are not moving in the same direction, there is no current. For creating or for moving the charged particles in the same direction, we want to use a battery, or we want to use this kind of point. So when you have this in your home, you have this connection, earth, live wire, neutral wire. Then this live wire, neutral wire is creating what? A potential difference. Remember that. Don't think current comes from there, nothing comes from there. It just creates potential difference. One live wire is at 220 volt, neutral wire is at 0 volt. So automatically it creates a potential difference of 220 volts. So when I put two wires inside, whatever electron is there in my wire, that starts to move in a direction, that produces current, and your appliance starts to work. Never ever think that battery is giving current, never it gives. Battery just gives energy, chemical energy. And what it is used for? It is used for making the charged particles to go from lower potential to higher potential. Because from higher potential to lower potential, it will move by itself. Just because you put a battery in a circuit, the charged particles will automatically move from where to where? Higher potential to lower potential. From lower to higher, it cannot go by itself. For that only chemicals in the battery is used. Okay? This concept I have taught you in detail when I was teaching you about potential difference. From here once again questions can come. You have the value of Q is equal to NE. So any question can come where they may give you W, Q, they may ask to find the potential, or they may give you V and Q, they may ask to find work done, or they may give you V and W, they may ask you to find Q or N. This kind of questions will come in the examination where they may give out of these three, two data, and they will ask to find a third data. Numericals comes from here. Then in this chapter we have learnt about Ohm's law. What is Ohm's law? What is Ohm's law? Ohm's law gave the relationship between potential difference and current. So Ohm conducted experiment to find what is the relationship between potential difference and current, and he found that potential difference across a conductor is directly proportional to the current flowing in the conductor. And if you remove proportionality, you have to add a constant. That constant was called as what? R, resistance. So from here you know resistance is equal to V by I. V is in volt, I is in amperes. Volt per ampere is called as ohm. Volt per ampere. It is also called as ohms, OHM, given by this symbol, ohm. See, we are learning three new topics here, three new actually quantities here. Current, coulomb by second, ampere. Potential difference, work by charge, which is joule by coulomb, volt. Resistance, volt by ampere, ohm. From here, from all these three, these three, they may ask you define 1 ampere of current, or they may ask you define 1 volt of potential difference, or they may ask you define 1 ohm of resistance. Whether they ask you to define 1 ampere, or they ask you to define 1 volt, or they ask you to define 1 ohm, the way of defining is same. What is that? You should define 1 ampere is that current which is generated when 1 coulomb of charge is moving across a conductor in 1 second. So if 1 coulomb by 1 second, you are going to get 1 ampere. So if 1 coulomb of charge is moving through the conductor in 1 second, then the current produced will be 1 ampere. Same way, 1 volt is that potential difference which will enable 1 coulomb of charge to have an energy of 1 joule. So if 1 joule of energy is applied to move 1 coulomb of charge from one point to another point, then the potential difference is 1 volt. Same way, if 1 volt of potential difference is applied to produce a current of 1 ampere, then the resistance will be 1 ohm. That is the way you can define 1 ampere or 1 ohm or 1 volt. Anything may be asked in the examination. Okay. Then we learnt very important part of this chapter, from where the question is certainly going to come in the exam, which is factors on which R depends. I told you R depends upon 4 factors. Factors governing R. What are the 4 factors? First factor I told you was length. Second factor was area of cross section. Third factor was nature of material. And fourth factor was temperature. It means that if 2 wires are having different lengths, then they will have different resistance. If 2 wires are having different area means area of cross section, thin and thick, they will have different resistance. If the wires are different, obviously they will have different resistance. Aluminum and copper will not have same resistance. And if we have different temperatures, resistance will be different. It's a very important thing I am telling you. Resistance depends upon length, area, nature of material and temperature. So if I just do mathematical part of it, where I write R proportional to L and inversely proportional to A, if you remove proportionality, you have to add a constant, and that constant is called as rho. R is equal to rho into L by A. It is called as resistivity. Rho is called as resistivity. Now what is speciality of this resistivity? Resistivity does not depend upon length and area of cross section. It depends only on nature of material and temperature. This question has come in the board exam many times. Factors governing resistance is 4: length, area, temperature, nature of material. Factors affecting resistivity is only 2: nature of material and temperature. It means if 2 wires, like copper wire, 1 meter copper wire, 2 meter copper wire, they will have different resistance. But 1 meter copper wire, 2 meter copper wire, they will have same resistivity. 1 millimeter square, 1 centimeter square copper wire will have different resistance. But 1 millimeter square, 1 centimeter square copper wire will have same resistivity. Copper wire and aluminum wire will have different resistance and different resistivity. Copper wire at 100 degree, copper wire at 500 degree will have different resistance. Copper wire at 100 degree, copper wire at 200 degree will have different resistivity also. This kind of questions can come to you in assertion and reasoning. Remember that in the board examination. So factors that affect resistance are 4: length, area, nature, temperature. Factors affecting resistivity is only 2: nature of material and temperature. If I tell you how it depends, as I told here, R is proportional to L. It means more longer wire, more resistance. To understand this concept, you just understand that resistance is caused by the collision of electrons inside the material. For example, if I am having a wire, in this wire, if there is some resistance, why this resistance comes inside? Because the electrons are colliding here and there. Collision of electrons inside a metal or a conductor creates resistance. So common sense says that if I am having a longer wire, it will have more electrons. If it has more electrons, it will have more collision. It will have more collision, it will have more resistance. I told you now, resistance is what governs the, resistance is governed by the collision of electrons. So if you have more longer wire, it has more electrons inside. If it has more electrons inside, there is more chances of collisions inside. So obviously it has more resistance. Same way, if you have, you can see from here, R is inversely proportional to area. If there are two wires, one is a thin wire, one is thick wire, then again common sense says that if the wire is thick, the collision will be less because it has more space for the electrons to move. Wire is thin, it has less space, more collision will be there. So thin wire has more resistance, a thick wire has less resistance. That's why resistance is inversely proportional to area of cross section. Then we have learnt about how to solve numericals coming from here. Once again I am repeating, numericals from here are a certain question in the board examination. Again I am repeating this. Expect one question in the board exam to come where you will have a numerical coming from this chapter, from this topic actually. And what numerical will come, that is what I am telling you. There are two kinds of numerical possible from here. One numerical is on the assumption that the same wire is elongated or compressed. That is, they will give you a wire, they will give you its length, they will give you its area, and they will give you its resistance. A wire will be given, suppose 2 meter wire, 2 meter long, 1 centimeter square cross-sectional area, and it has a resistance of 10 ohms. If the wire is made 2 times longer by stretching, that is, length became 2L now, what will be the new resistance? Is the question clear? The first kind of question can be, length will be given, area will be given, resistance will be given. Then they will say the same wire is elongated, pulled and made longer. Now what is its resistance? It will change? Yes, it will change, because I told you different lengths will have different resistance. But what will remain same? Its resistivity will remain same, because it is material property. Somebody, what they will do? They will say R dash will become equal to rho into 2L by A. So it will become 2 times of rho into L by A, and rho L by A is for this material, isn't it? Here R will become equal to rho into L by A. They will put here and they will say R dash became 2 times of R. It is wrong. Why is it wrong? It is wrong because you are not considering the area here. When a wire is stretched to become long, it will also become thin, isn't it? I hope you are understanding my point. If something is stretched, it becomes long and becomes thin. So if its length is increasing, area will also change. If area changes, how much it will change? You have to find it. And how do you find it? You find it by using the concept of conservation of volume. In math also this year, when you learn about surface area and volume, you will learn about the same concept. Okay? You have a bad day today. Today you are going to severely get beating from me. Remember, Ranit, you have not seen my face, no, today. Today you will see while going. So again I am repeating that in 10th mathematics also you are going to study about, in surface area and volume chapter, you are going to study about how conservation of volume works. They will say that a cylinder is being converted into a hemisphere or a cone or a sphere, and then they will ask you to find the surface area of it. What we will do, we will find volume of a sphere, volume of a cylinder, equate it, and then find the radius relationship. These kind of questions will come in the math also. The same logic applies here. So their volume remains same. What is the volume in this case? L into A. Don't you agree with me? Area of cross section multiplied with the length will give the volume. In this case, what will be the length? L dash. What is the area? A dash. So L into A becomes equal to 2L into A dash. L gets cancelled. A dash will become equal to A by 2. It means when I took here A, that was a mistake. It will become A by 2. So it will become 4 times of rho L by A. the answer will become 4R. Common mistake done by the students is this. I am telling you based on my experience of 15 years teaching. Many people, when they write the examination, they will think length is 2L, directly they will use 2L and solve, and they will get a wrong answer. One category of question is this. Second category of question is, they will say there was a wire of length L, area A, resistance R. Another wire of same material, but twice the length is taken. What is its resistance? Then the answer is 2R only. Because now they are not stretching it, area will not change. In the previous case, I stretched the wire to become 2L, so area got reduced. If they itself say in the question, there is a wire of length 1 meter, area 1 centimeter square, its resistance is something 10 ohm. If another wire of same material is taken which has a length of double the length, what will be its resistance? Obviously it will be double. Common sense, right? Because R dash will become equal to same formula, rho into L by A. L dash A will not be remaining same, nothing that mentioned here. So rho into L dash will become 2L by A, which will become 2 times of rho L by A. So R dash will become equal to 2 times of R. So what is the challenge here is identifying whether the question is from this category or this category. Both are possible. Both are possible. If they mention a wire is compressed, a wire is elongated, use conservation of volume concept. If they say nothing about same wire is elongated or anything like that, they just tell that another wire was chosen, then never use conservation of volume concept. I hope you understand my point. Okay? This kind of numericals may come in the examination. Then you have learned in the previous class about series and parallel connection of resistances. See, whatever I am doing from last half an hour is revising what I have taught. Nothing I am teaching new today up to now. It is what I am doing is recalling. I am doing mainly for this Tanuja and Vaishnavi only, because they are sitting in the first class. So I am not starting with my today's topic. I am continuing with my previous classes only. I am revising everything. I hope you are understanding. Tanuja, understanding anything?
Yes, sir. Everything understood.
Okay. What about you, Vaishnavi? You understanding?
Yes, sir.
Okay. Now please pay attention. Series and parallel connection of resistances. So if you have resistors like this, they are said to be in series. If you have resistors connected like this, they are said to be in parallel. Now what you have to remember is that in the case of series connection, the current remains same throughout. What current enters here? The same current passes. What resistance will do? It will slow down the current, it will not change the current. If 2 ampere enters here, 2 ampere only will exit here. I hope you get my point. And each resistor will have 2 ampere current only. If you have 5 ohm and 10 ohm resistance, it means that this 5 ohm will make it to go slower, 10 ohm will make it to go more slower. So understand the resistance, it will not reduce the current, it will not increase the current, it can just slow down the current. Are you getting my point? So resistance is opposition towards current, not cancelling the current. It will just oppose it. It cannot stop it. It cannot change its value. So whatever current flows in series connection, the current value remains same throughout the resistance. And what changes? The potential may change based upon the resistance. Suppose it is R1, R2, R3, it will become V1, V2, V3. Because we know by Ohm's law V is equal to IR, it will become IR1, it will become IR2, it will become IR3. You may ask me, sir, what if all three resistors are same? 5 ohm, 5 ohm, 5 ohm. Then it will be same. 5 into 1 I, 5 into I, 5 into I. But if they are different resistors, 5 ohm, 10 ohm, 15 ohm, then it will be 5I, 10I and 15I potential drops, right? So in this case, in series connection, the net equivalent resistance, we have derived it, I am not doing it now, you can see the previous class lectures. R equivalent value is R1 plus R2 plus R3. It means if resistors are in series, their net value is addition of all the resistances. Remember this. If resistors are in series, their net value is what? Addition of each value. Suppose you have 5 ohm, 10 ohm, 15 ohm, then the answer is 30 ohm, R equivalent value, because 5 plus 10 plus 15 will give you 30. So 30 ohm is the equivalent resistance, net resistance, total resistance, whatever you call it. Whereas in the case of parallel connection, the currents gets divided, isn't it? I1, I2 and I3. Why I say so? Common sense again. When the current is coming, it has 3 paths now. Suppose 5 ohm, 10 ohm, 15 ohm. Then more current will go in 5 ohm, less will go in 10 ohm and least will go in 15 ohm. The path which offers the maximum resistance, least current will go there, and the path which offers the minimum resistance, maximum current will go there. I hope you are getting my point. So in this case, the current will get divided, but what remains same? The potential remains same. So you should always remember, in series connection, what is same? Current is same. What is divided? Potential difference is divided. In the case of parallel connection, what gets divided? Current gets divided. What remains same? Potential difference remains same. Never forget this, because on this logic only we derived what we derived, this R equivalent value itself, and when we derived for this, we came to know that 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. In the previous class, we have solved 5-6 questions also, where I told you how to get solve the numericals from series connection or parallel connection. Again, from my experience, if I tell you, many students what they will do this step, but they will forget to reciprocate. Question will be like 2 ohm, 4 ohm and 6 ohm are in parallel. What is the value of R equivalent? What they will do? 1 by R equivalent is equal to 1 by 2 plus 1 by 4 plus 1 by 6. Then they will take LCM. LCM will be 12, 6 plus 3 plus 2, 9 plus 2 is 11. They will say the answer is 11 by 12. Wrong. Why it is wrong? Because 1 by R only is 11 by 12. What is R equivalent then? 12 by 11. Again I am saying, out of 100 students writing board examination, at least 45 will do this mistake. 50% people will do mistake here in the examination. In a hurry, they will forget to reciprocate, and they will report the answer in 11 by 12. Gone. Fully wrong. What is the answer then? 12 by 11. Don't forget this step, reciprocating the final answer, because you are finding 1 by R, not R. I hope you get my point. This kind of mistake students are doing, avoid doing that mistake. One more thing I will say you. This I told in the previous class also to you, once again I am repeating it. Keep this in your mind. Whenever resistances are connected in series, the net resistance value is greater than the greatest value of resistance. For example, if you are having 1 ohm, 2 ohm, 5 ohm, 11 ohm, 15 ohm, 20 ohm connected in series, the final value will be more than the maximum value. Are you understanding? If you have 1 ohm, 2 ohm, 5 ohm, 10 ohm, 15 ohm and 20 ohm in series, then the R equivalent value will be more than 20 ohm. And if I am having 1 ohm, 5 ohm, 10 ohm, 15 ohm and 20 ohm connected in parallel, then their answer will be lesser than 1. So whenever resistors are connected in parallel, the final answer is less than the least value. Whenever resistors are connected in series, the final value is more than the maximum value. So whenever you want to increase the resistance, what do? You add a higher resistance in series. Whenever you want to decrease the resistance, you add a lower resistance in parallel. Suppose I am having 1 lakh ohm here. I am having 1 lakh ohm, and for my circuit I want to make it 1 ohm. I want to convert 1 lakh ohm less than 1 ohm, I want to make it. It's very simple. Just connect 1 ohm in parallel, over. For 1 lakh ohm, if I am connecting 1 ohm in parallel, R equivalent will become how much? Less than 1. Approximately 1 ohm it will become. Same way, I am having 1 ohm and I want to make it 1000 ohm. Just make 1000 ohm in series, over. I hope you are getting my point. This logic will be used in 12th standard also. Again, you will not find this in the book. I told you it is important for you in the future also. So, series connection, net value is more than the maximum value. In parallel connection, net value is less than the least value. Always remember that. Before closing my last class, I gave a question to you. Anybody solved that question? I remember I gave a question. Those who were there in the class. Were you there? Ashwarya, you were there in the class, right? What question I gave you? One second. 2 ohm, 3 ohm, 6 ohm. Huh. 4 ohm and 1 ohm. It's a very interesting question. If this question you are able to solve by yourself, your concept of resistors in series and parallel is completely clear. If you are unable to solve, then you have some issue in the concept. What the question was, I am giving you 3 resistors, 2 ohm, 3 ohm and 6 ohm. Connect and give me the final answer as 4 ohm. This was the first part. And second part was connect in such a way that the answer becomes 1 ohm. Series will never give me this answer because series will give me 11 ohm. Parallel, have you tried this? How much parallel will give you? 1 by R equivalent will become equal to 1 by 2 plus 1 by 3 plus 1 by 6. LCM will be how much? 6. 3 plus 4. 2 plus 1. How much is that? 6 by 6. So 1 I got actually. So 1 by R equivalent becomes 6 by 6. So R equivalent become 1 ohm, right? So the second part is done. Very simple part. It means if I connect 2 ohm, 3 ohm and 6 ohm in parallel, I am going to get 1 ohm. Simple. Anybody could get the answer for this 4 ohm? Huh?
Sir,
Yeah.
we have to connect 3 ohm and 6 ohm in series, sir.
Then?
Sir, then 1 by R1 will be equal to 1 by 2.
Okay. So 1 by R will become equal to 1 by 3 plus 1 by 6, which will give me 6. It will become 2 plus 1, which will give me 1 by 2. So R becomes 2. Yeah. Then?
Then we have to add the 2 ohm and this with series.
You should not do like that, man. You should connect together always. Actually, you are saying they are in parallel, right? Sorry, not in series. You are telling to connect 3 ohm and 6 ohm in parallel, right? Preetham?
Yes, sir.
Yeah, this is fine. And 2 ohm in series. This is only you are telling, no?
Yes, sir.
That is correct, yes. This is correct, guys. I hope you are realizing. So 3 and 6 are in parallel. It will become 2, and add one more 2 in series, it will become 4. This kind of question will come in the board exam. They will give you a set of resistors and they will ask you connect to get this value. Now you may think that, sir, how will I get this, because I have so many possibilities. I can have 2 and 3 in parallel and 6 in series. I can have 2 and 6 in parallel and 3 in series. Then how will I come to this conclusion that out of all the possible choices is my answer? That will come only by practice. That will come only by practice and common sense again. Because if I think that I will connect 2 and 3 in parallel and 6 in series, it can never be possible, because the answer will be more than 6 only. So it cannot be this. Second way is connecting 6 and 2 in parallel and 3 in series. That is possible. Check and try. It will not give you 4. So only way to get 4 is having 3 and 6 in parallel and 2 in series. This kind of question definitely will come in the examination, school exam. Yes, tell me,
Is it
Tanuja.
necessary to use all the series in you?
All the? Resistors they give.
Yes, sir.
Yeah, definitely you should use. That's what that's what the question is. You must use 2, 3 and 6, all 3 and get the answer as 4. That is the question.
Okay, sir.
So the only possibility is this.
Okay, sir.
I hope you are getting my point. Those who could not get the answer,
sir.
yes. Clear? Up to here we have seen in the previous class. Let us learn today's class topic. On small topic is there, we'll finish the topic. Okay? Give the heading as heating effect of electric current. Heating effect of electric current. Okay.
Sir, that is not a small topic.
Why you are saying not a small topic, man?
Sir, the derivation itself is very big, sir.
Very big. Let us see how much the steps it takes now. Okay.
Sir, to understand and learn it will be very big, sir.
Let us see, man. If you don't understand, tell me that you not understood. Okay, pay attention. So, who found this effect of heating effect of electric current? Any idea? Huh?
Joule, sir.
Joule. So write down the first thing. Joule found the heating effect of electric current. Joule found the heating effect of electric current. That's why it is called as Joule's law of heating. Joule's law of heating. Why it is called as Joule's law of heating? Because Joule was the scientist or the physicist who found this. Joule is the name of the person. Joule, Joule. So Joule found this heating effect of electric current, and that's why it is called as Joule's law of heating. Now how did he find that? By doing experiments, it was found that whenever current is flowing in the wire is becoming hot. You should have felt the same thing, right? Like TV is running for a long time, touch TV, it will become hot. Light is going for a long time, touch the light, it will be hot. This is going for a long time, touch, it will be hot behind. So always whatever mobile phone we are using too much becomes hot. So whichever device there is electricity going, that is cold, you are saying. AC is cold. Go and touch the inside thing where the circuit board is there. Okay. So whatever electrical appliance where the current is involved, it will create a heating effect. That was felt when we are using current itself. Joule quantified it. That is, Joule found the formula and he found the reason why are we getting this heating effect. What he told, please pay attention, very simple thing. I will give time for writing, please pay attention. He said that, as we know, don't write anything now, I may erase also, I may change also. Let's just understand the concept first. We know that potential difference is equal to work done per unit charge. Do you agree with me? Do you agree with me? And from here I will get work done is equal to V into Q. Common sense? This work done only is the energy. Do you agree with me? What is energy? 9th you studied. Capacity of doing work is called as energy, right? Energy and work have same units. Joule. You remember this in 9th standard. Work is force into displacement. Energy is capacity of doing work. Energy has same unit as work. These things you should study in 9th itself. I hope you studied. So this energy can be written as the heat energy, can be written as V into Q. Can I write like this? Now, what is Q? We also know that I is equal to Q by T, right? So from here what we will get? Q is equal to I into T. So this is equation number 1. I can write it here. H will become equal to V into I into T. Can I write like this? Yes, not VIT Vellore. H is equal to VIT. How it came? From equation 1. Do you agree with me? And we know V is equal to IR. From Ohm's law, V is equal to IR. From what? From Ohm's law. So I can write H is equal to IR into IT, which will become H is equal to 2i. I into I is 2i. Great. I square RT. This is called as Joule's law of heating. Mr. Nitin Raghav, big derivation.
Sir,
What?
okay, sir.
Take,
Okay, sir.
take my statement back. Okay, okay.
Of course, sir.
Hmm.
In 2 minutes.
Yeah, it's not something very big.
Please.
Yeah, whatever. So heat energy will become equal to V into Q. And what is V? IR by Ohm's law. What is Q? IT by the formula of I is equal to Q by T. Put in the equation, get the answer. VIT, V is IR, I square RT. That's all. This is the derivation for Joule's law of heating, where H is equal to I square RT. So this is called as Joule's law of heating. Joule's, can I? What I should write? I wrote only, no? What do you want me to write? She wants to copy. Yeah, she can, you can write. Copy it fast. Yes. Tell me, Sahitya. Be little louder here. I am not able to hear you.
Can you explain it again?
I'll explain it to you once again. Please pay attention. Okay? Give me 2 minutes. Let them copy. I'll erase and I'll do once again for you. Okay? Yes. Have you copied it? Fast. I'll erase it once again and I'll do once again. Daksha copied, right? Okay. Here, Srinidhi, Aishwarya copied. Fast.
Sir,
Yes.
when the work is you have written as energy now, sir,
Yes.
that energy could even imply electrical energy also, no, sir?
Yes, it can imply electrical energy also. But here we are measuring by using calorimeter and we understand that there is some heat energy produced. That's why we are concluding it is heat energy. It can be taken as electrical energy also, by the way.
Okay.
Okay. I am going to the next page now. Everybody please pay attention. Sahityashri, especially for you. I am once again doing it. Please pay attention. So basically we are using two formula here. What we are using? One formula we are using for potential difference. I revised today also that potential difference is equal to W by Q. You remember this, Sahityashri, you know this formula? Potential difference is work done per unit charge. And we also know current is equal to charge per unit time. Am I right? Both are known to you? Yes. So instead of charge, I can write, so V will become equal to what? V will become equal to W by, instead of Q, I am writing IT. Instead of Q, I can write IT, isn't it, Sahityashri? So I am writing V is equal to W by IT. This work done is there, no? This work done only is stored as heat energy. Why I say so? Because work done is only energy. Capacity of doing work is energy. As you studied in 9th standard, capacity of doing work is energy. So we can replace work with energy, and I can write heat energy is equal to V into I into T. If you are hearing, I hope you are understanding. And further, if you want to write, you can write H is equal to, instead of V I am writing IR into IT. How it came? Since V is equal to IR, which law is this? Ohm's law. So I am going to get heat energy H is equal to I square RT, where H is heat energy, I is current, R is resistance and T is time. Now please pay attention. There are three formula possible for heat energy. One formula is H is equal to VIT. One formula is H is equal to I square RT. Another formula is possible. Instead of writing I can write V by R. So don't you think we can also write H is equal to V, instead of I am writing V by R, it will become V square T by R. Possible, right? This can confuse you. Why I am saying so? Because here H is proportional to R, here H became inversely proportional to R. If they ask you whether heat energy is directly proportional to R or whether it is inversely proportional to R, if you have two bulbs, one is having 10 ohm resistance, one is having 20 ohm resistance, which will have more heat energy produced? Why? H proportional to R, so 20 should have more resistance, should have more heat, and H inversely proportional to R, less should have more heat. This is the point of confusion. Many will confuse in this, because one formula is saying H is inversely proportional to R, one formula is saying H is proportional to R. What is true? Why? Looks more true to you. Practical, don't they? Yeah, practically both are true. I'll tell you now how. Depends upon the
If the current applied to both the bulbs equally means, then voltage also differs, sir. In that case, we can say the 20 ohm resistor
will have more
more heat.
heat. See, common sense. Please pay attention. Remember this. If I and T are constant, then only H can be proportional to R, no? When will current be constant? In series connection. I told before some time to you. So if bulbs are in series, then heat energy will be proportional to resistance. If V is constant, which happens in the case of parallel connection, H will become inversely proportional to resistance. It means if I have two bulbs, pay attention guys, this is having 10 ohm resistance, 30 ohm resistance, which will have more heat energy, 10 or 30? Common is 30. Because if it is a series, current must be same. Current must be same means current will become constant, H becomes proportional to R. Same way, same 10 ohm and 30 ohm in what? Parallel. 10 will be having more heat energy. Are you getting why? Because now what is constant? V is constant. If V is constant, heat energy is inversely proportional to R. Lesser resistance will have greater heat energy. Is it clear to you? Tell me. You are not knowing because you are not minding it. The person who has made this wiring, they will know it, right? If I am doing the wiring of this room, I know that this is series, this is series. Usually I will tell you about one topic is there, domestic electrical circuit. I will teach that to you. In that you will come to know that in our home, if you have all the rooms, everything should be in parallel. Because if you put in series, one appliance stops working, everything stops working. Isn't it? If you have a series, this bulb stops, it won't let the current go. But in parallel connection, if one stops working, one keeps on working. We don't give series in home. Are you getting a point? This is we will learn in next class, where we will learn about how the wiring is done for the home. Domestic electrical circuit. Okay, this topic is there in the syllabus. I hope whatever I have taught you today, you have understood. And once again I am repeating, please pay attention, especially the new students. Many places we will use, we'll talk about that, okay. Like fuse there, no, in a home fuse. Fuse should always be in series. Because if fuse is in parallel, current will go inside. What is the use of fuse? Extra current comes, more current comes, you should stop it. It will melt, it will melt and stop it. So if you have in parallel, then what will happen? More current will come, it will go in all the home appliance. If it is in series, whatever comes to your home should pass and go fuse. So it will melt if extra current is coming. We will talk about that in next class. Okay. So I am winding off here. Again I am repeating, people who are new today, I am going to share the link of all the class videos of electricity chapter. This chapter, whatever I have taught in the previous class, I will share the link in the group. I hope you are added in the group. Vaishnavi and Tanuja, you are there in the WhatsApp groups?
Yes, sir.
What about you, Vaishnavi? Are you there in the WhatsApp group?
No, sir, I am not in that.
I will first add you. After adding you, I will share the videos of the previous classes. One second. I will add you also. You are also not added. I will add you. After you are getting added, after getting the video link, even you people, those who are absent for the previous class, see the video, take the notes, and next class, I am not going to start next chapter. I am going to once again take numericals of this chapter. Okay, to make this chapter more strong, I will once again revise whatever you want me to revise, and we will start taking the numericals from electricity chapter. So next class, please see the videos, get the notes and come. Then only you can understand my next class. Okay, guys, bye bye, take care.